Today in the probability of multiple events section, we are going to talk about the probability of event A and B occurring versus the events A or B occurring. So to find the probability of two events occurring together, you have to decide whether one event occurring affects the other event or not. When the occurrence of one event affects how the second event will occur, they are called dependent events. Otherwise, if they don't affect each other, they are independent events. So let's say that we want to classify this as either dependent or independent. You select a coin at random from your pocket. You replace the coin and select again. Are you selecting independent events or dependent events? They are independent. Why? Because if I pull a penny out of my pocket and put it back, because of the replacement, it is independent. I have the same amount of choices for my second coin that I'm going to pull out of my pocket. If I did not replace it, it would have been dependent. So take note, if we're talking about the probability of A and B occurring, what we're going to do is multiply the probability of A times the probability of B. So your AND implies that you're going to multiply your individual probabilities. So at a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what's the probability that you will get a regular drink and regular chips? So the probability of regular drink and regular drink, that is equal to the individual probability of getting a regular drink and then multiplying it by the probability of getting a regular chip. So the probability of a regular drink, there are 5 regular drinks out of a total of 15 drinks possible. 10 plus 5 is 15. And the probability of getting a regular chip, well, there's 8 bags of fat-free and 12 bags of regular. So we got 12 out of 8 plus 12 is 20 bags. And then we're going to multiply these two together to find the total probability. I could reduce these before I do my multiplication. Or I could plug them into my calculator and learn that this is 1 out of 5 chances that I will get a regular drink and regular chips. And your passcode for today is CHIPS, C-H-I-P-S. 2 events that cannot happen at the same time are called mutually exclusive events. If A and B are mutually exclusive, then the probability of A times B is going to be equal to 0. So, for example, rolling an even number and rolling a prime number. Even numbers are 2, 4, 6, 8, and so on. And rolling a prime number, well, prime numbers start at 1, 2, 3, 5, 7, and so on as well. There is one number that is both even and prime, so these are not mutually exclusive events. However, if I roll an even number and a number less than 2, so an even number would again be 2, 4, 6, 8, everything divisible by 2, and rolling a number less than 2, the only possible roll from a die less than 2 is 1. These do not have any elements in common, so these are mutually exclusive. So probability of A or B means that we're going to add the probabilities of A and B and subtract the probability of A and B together where they overlap. And so or means we're going to add, remember, and meant we would multiply. Also note that if they are mutually exclusive, we know that the overlap is equal to 0, so we're simply going to add the probabilities of A and B together. At your high school, a student can take one foreign language each term. About 37% of the students take Spanish, 15 take French, and about 9 take Mandarin Chinese. What is the probability that a student chosen at random takes Spanish, French, or Mandarin Chinese? Since they only can take one foreign language each term, that means that these must be mutually exclusive. So all we need to do is simply add the probability of Spanish plus the probability of French plus the probability of Mandarin Chinese. And the probabilities are the percentages. So there is a 0.37 chance that the student will take Spanish, a 0.15% chance that they'll take French, and a 0.9% that they'll take Mandarin. So 0.61 or 61% of the students will be taking either Spanish, French, or Mandarin. Now suppose you select a token at random from the dish above. What is each probability? In part A, we want to know that the token is either square or red. So square or red. Well, because there is an item that is a square and red, these are not mutually exclusive. So what we're going to need to do is find the probability that it's a square, add the probability that it's red, and subtract the probability that it is square and red. So the probability that it is a square, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 tokens on this plate. And of those 9 tokens, 3 of them are squares. Of the 9 tokens, 3 of them are red. And of those 9 tokens, 1 of them is a red square. And I'm not going to reduce these yet because I'm adding and subtracting fractions. I want that common denominator. So 3 plus 3 is 6, minus 1 would be 5 nines. 5 out of 9 chances that we will get a square or red. Now for part B, we're looking at the probability that it is green or a square. And the question is, do we have any green squares? Yes, we do. So these are not mutually exclusive. Again, So I want to find the probability that it's green, add the probability that it's square, and subtract the probability that it is green and a square. So probability that it's green, 3 out of the 9 tokens are green. 3 out of the 9 tokens are squares. And 1 out of the 9 tokens is a green square. So again, I get a probability of 5/9.